What's up, everybody? Welcome to another video brought to you by OCCC, Old Crow's Classic Cars. OCCC, get it? Alright. Anyways, in this video I will be showing you guys I just noticed that I always say anyways, I'm going to show you guys how to a couple maintenance procedures for a big industrial welder. In this case, my Tig Airco Welder. That's what it is there. Airco is the brand. So as I was trying to weld, I was getting a loud rattling sound, almost like, but much worse than that, like really like rattling. And probably one of the first things you'd want to do, which is what I did, is just open up the machine and give it a good clean. Make sure the machine is on when you do that, right? Just kidding. Make sure it's off. Right? And one day I would like to go a little bit further still and actually paint this. But anyways, right now I just use the air nozzle here. Just use one of these to really clean it out. And by the way, guys, this one here, this pointed one, is a lot more powerful than this one here. This one's supposed to have like a Venturi nozzle effect, whatever, and it's got the special nozzle here, and I mean, I guess it's maybe higher volume, I don't know, but this one just works way better than that one. So but anyways, I just cleaned it up, and you'll have here some of the major components. This big huge unit here, it actually is able to operate up to 600 volts, 575 perhaps, not quite sure, but anyways, that's not much of a difference. 575 to 600, yeah, that works fine. Okay, yeah, so it is a huge unit. You can't lift it up. I can barely lift it up in one end. It's really heavy. And so right here in the middle, actually right here on the left, you've got just a big fan, and it's more like a radiator fan. It's massive, man. Once this thing is on, it sounds like a car. And obviously this just refrigerates, cools the machine. Over here in this section, we've got the motor for the fan. There's the fan motor there. And over here, pretty much the same thing. You'll see that there's this big thick wire connected here. Now what this is the rectifier bridge, and it's got like big round things on it. I'll zoom in. Let me see if I can zoom in. So I'm just gonna put the you see this thing here? Right at the end of the never mind, I'll zoom in, hang on. Right at the end of the okay, right there, that big round thing, and usually there's 4 of them, and this is the same on pretty much on any welder, except for perhaps for the inverter, electronic technology ones. And there's usually 4 of these. There's the other one right there. These other smaller round things, they are capacitors, I believe. Not really sure what they are for, but anyways, these big round things there, They are rectifiers. I'm actually not sure if that's what they're called, but this whole thing here is a rectifier bridge. What this does, it gets the alternating current voltage from the regular household supply. In this case, actually no, I'm gonna finish this anyway. Get this, and it converts it to direct current. You need direct current for welding, unless you're welding aluminum. In that case, you need the alternating current, but at a much higher frequency. But anyways, in most cases, for most types of steel, brass, stainless steel, most of the regular sort of heavy metals, this you need this part here, the DC converter, pretty much. All right, and then right here in the middle, we've got the big, massive transformers, and there's actually like a massive one at the bottom, two massive ones at the bottom, and then another one on top. It's just huge. From here to there, it's just transformers, and this just takes the high voltage and converts it to a lower voltage, but a much higher current. Once again, this is for welding. For welding, you need really high current. Just think of it this way: the high voltage wires that you see running on the just high tension wires that you see everywhere, they're like 10,000 volts, and the wire's like thin, right? But the amperage is very small. For welding, just like a car battery, the wires are much thicker because you need smaller voltage but a higher current. I'm not going to go into too much detail on that. Anyways, and then here same on the other side, you have the range selector. You have a maximum, minimum, and a medium on this side, right? And again, this is done mechanically, which is why these machines here, doesn't matter how old they are, they never break. They're very, very well built. These wires here, by the way, they're pretty much not wires, they're more like solid bar. And they're very, very, just very, very well built. The connections are all with standard bolts and nuts, which is great. Alright, so yeah. On the other side, you have either the selector for direct current, standard polarity at the top. In this case, alternating current in the middle. And way at the bottom, you have reverse polarity, direct current. So with direct current, usually you have a negative ground, I think. Yeah, I think it's a negative ground. And on the ground wire here, this one, negative ground, and the electrode is positive. Then obviously on the bottom it's the reverse. I'm not exactly sure the polarity, but anyways, one is a standard, the other one is just direct current reversed, which is more suitable for some materials. Alright, and then there's actually another transformer there. Alright, now, following that really loud rattling sound, I found that it was coming from the main relay there. Zoom in, motherfucker. That part there. Alright, so this is just a big, massive relay, and it's got three. It's composed of 3 tabs, but they're all connected to the same point. So they could have just put a big, massive point instead. That would have worked too. But anyways, this is just a big relay, and I just opened it up, cleaned it up. The terminals the points were pretty well worn out and corroded. But I just put it back, cleaned it up. It seems to be working fine now. It won't break. This thing is pretty much invincible. And once again, there's a little transformer inside which pulls a coil in basically and closes the big points for the electricity to flow. Right here you have a circuit breaker. Right now, so for the maintenance, what I did is I removed the big relay here and cleaned it up. That's the important part of the maintenance here. The other good thing to do is just put some oil on all the bolts, just a little bit, just to make things easier in the future if you ever have to loosen one of these up. It's really easy, and just to prevent, that green stuff, mold, whatever, forming there. For this next part, the other thing I did is sand the points of those 3 relays there. So, zoom in. Just like a car, you gotta clean up the points on the voltage regulator. This thing here controls the high frequency, and from what I understand, they just vibrate at thousands of times per minute. But anyways, what I noticed is you can switch. There are 3 selections on this particular machine. I'm pretty much for most of them. You can either turn high frequency start off. You can turn the high frequency off, continuous, or start. So if it's off, you'll have to scratch start the TIG. Right, you actually have to scratch it against steel to start, which is not really nice because you can't. I mean, it sort of corrodes the electrode. Yeah, it corrodes the electrodes, and it's just not a good way to start a weld. I'm sure there's videos out there explaining why, showing why. But anyways, that's not good. So you can turn it on continuously. But for steel and, stainless steel and most heavy metals, you don't want the current to be fluctuating. You want it to be direct. So for most cases, the position is on start. For some reason, it's much easier to start an arc with high frequency. All right, so usually switch that on, turn that switch to start, and it'll just give a high frequency just at the start. As soon as it starts welding, it stops, and that's what you want. That's what I usually want, especially for steel. What else? So, and there's lots of points here, and you just get some sandpaper and use it to clean off those points, and then obviously air blast it later. And on the right here, you can see that looks like somebody replaced it. The only thing thus far that I could find to criticize this machine is on these relays. The points, the wires going to them, are welded or soldered onto them, which is annoying because if you ever wanted to replace one of these relays, it's a pain in the fucking ass. But I mean, these things are pretty much indestructible. You just need, like I said, to maintain them. Just sand it, clean it up a little bit. Perhaps you can adjust the attention here through these tabs. But for the most part, like I said, you won't have to replace them. But over here at the bottom, you can see somebody did replace them with one of them, with a modern one. And you can see, unfortunately, they put wires with the little tab at the end that you can just disconnect to just connect to something else. So replacing these become much easier. And this is a modern replacement, like I said. I'm not sure why there are 3 of them. There's obviously lots of little smaller things, which I don't know what they're for exactly. But these things, like I said, there's no electronics on these machines. So this is why these machines are invincible, guys. And like I said, I just had to clean it up, do a little bit of sanding, and she should be good to go again. Right here, this part, you've got the switch, the main switch. Like I said, it's a massive switch, as you can see. Just does what the name says, it turns the machine on or off. Oops, sorry. Right here at the top. Yeah, the switch there. Here at the bottom, then obviously has some smaller switches there, some contact points, and the sockets. Over here, this in the middle with lots of coils of wire. You don't want to fuck up these wires. This is a potentiometer or just a variable resistor, either name. And this just varies the current. You can decrease it or increase it. So, as you can see, it's fairly basic. You know, try doing this to like one of those electronic machines now that they have IGBT, inverter, something, technology. I appreciate the lightweight, and I actually have one. But these machines, guys, is what I really, really love. I value reliability and durability more than anything else. I don't care if it's heavy. I don't care if it's old. I just care for it to last. It's very, very annoying for me. Get to a job and start working on something and, you know, not be able to work or do something because, you know, a stupid electronic part broke. These things, like I said, this machine will operate up to 600 volts. So whatever you put through it, you know, it's indestructible. One more thing I'd like to show you, but I won't be able to, is where you change the voltage of the machine. On the other side, fortunately the plate here is still on, so you won't be able to see it. There's lots of terminals, and on those terminals there's a diagram on the machine already that shows you which terminals to disconnect and which ones to connect for the desired voltage. Right, so hopefully, I'm pretty sure most machines are like this. You can use it on a few different voltages, but you do want to make sure. So it's just basically still on that subject, still basically just like wiring a motor. You can either, depending on the wiring, you can reverse the motor, change the wire, or you can wire it to a different voltage, either 110 or 220 volts, 240, 220, whatever. Right? On the corner there, that's one really nice thing there. You have a circuit diagram there for the machine, which is really nice. Especially for somebody that really knows that stuff. Zoom in. Anyways, there it is. You can see it there. Alright, I think we're finished here. Just think. Okay, yeah, one more thing. We're way down there. You look at, there's a couple of what looks like 2 blue pipes there. Those are capacitors, and they are massive. Once again, capacitors, they're basically, I like to call them a fast battery. They're like batteries in the sense that it stores charge, but instead of releasing it from itself slowly like a battery does, it actually releases it all at once in one big burst. What that does, it just helps to ensure that the current here is direct. It because when we say, for example, 110 volts, we think it's always 110 volts, but in reality, it actually fluctuates. 117, perhaps 115. So in some places you'll actually find written 115 volts, right? Or 110 volts. That's because it's not always 110. And on the when welding, you don't want that, because a change in current, a change in voltage is going to affect the change in current, and it's going to, pardon me, it's going to change the weld. So that capacitor ensures that doesn't happen, and the physics and explanations behind it are out of the scope of this video, beyond the scope of this video. But that's what they do. These things are extremely dangerous. If you touch both ends with your hand, you might die, or you might at least get a really nasty shock. So it's imperative to be really careful with those things, and where the wiring goes, I'm not quite sure here, but it's over on this side, so just watch out for that and just keep that in mind, although you probably won't be doing this. Alright, so that's it. That's how you... Okay, yeah, let me just turn on the machine so you see how it sounds now. One more thing. In my case here, I have the ground terminal connected via a vice grips here, a pliers, grip pliers, whatever, vice grips, whatever the fuck they're called. And if this touches the ground, if this touches the welder itself, you'll get a problem. You'll get a short circuit. It'll go like that. Oh, pardon. Does it sound like a car? Right now I have frequency at start. And I'm going to press the pedal here. Hear that? It's more like a, there's no rattling sound now. Now it's just a, like a slight buzzing, sprinkling sound. That's going to give you a perfect weld. Hear that? That is perfect. Just 5 minutes of maintenance. Machine was obviously, sitting for many years, used in a very dusty environment. And it just needs a little bit of maintenance, like anything else, right? Let me just make sure I talked about everything. Yeah, the difference between this and the way it was before is really like night and day. It's unbelievable. I'm curious. It's never been this good. I never cleaned it this much. I'm curious to what the welds are going to be like. Probably much better than I've ever had them before. Like I said, I came to a point where I could no longer weld at all. Just rattling, and just really loud, almost like a broken engine, just rattling the fucking hell out of everything. Like I said, this thing, it would actually shake, it would actually vibrate. The main relay here it would actually vibrate violently, and that's something to consider too, because if the bolts that hold it are loose, let me just turn off the machine. The bolts that secure it are loose, then it's obviously going to vibrate and cause a problem too. You'll hear some rattling, but the rattling was actually coming from the inside of it. Now, the reason being is the points there, that those little relays are what control. Apparently, they go to the the terminal of the big relay and control it. So if you're not getting enough voltage or enough power to the big relay, then those massive points, they're like huge points. There's 3 sets of them, huge points. And then those points are turning on and off really rapidly. And that's what causes the rattling, basically. Right? So you don't want, although like on the voltage regulator of a car, you have those points actually vibrating at thousands of times per minute. Over here, this big relay, you just want it on when you're welding and then off when you're not welding. That's it. So, right when you hit the pedal, pretty much in this case. On when you're welding, let go, let your foot off the pedal, and it's off. You don't want it vibrating like hell. And that's what would actually happen with the arc. It would turn on and off repeatedly, and very annoying. But fortunately, it's a really easy fix, as you can see. And that's it for now.